Hi guys, so this is the third video on chain and product rules. We are going to tackle these four questions on the screen in front of you, and the focus of this video shall be on how to deal with slope questions and stationary point questions. So in a minute I'm going to start the first problem. So our first question came in November 2010, question number 2, and this actually came in paper 1. So we are required to find the derivative of 2x sine x. Take a minute, pause the video, try to do this on your own, and then check the answer. So before I start my explanation, you might want to look at the answer, pause the video, and I'm going to begin my comments in a minute. So the first question is requiring that we differentiate the function. We find g dash of x. So if g of x equals 2x sine x, then we are going to use the product rule to obtain the derivative function, which shall be 2x cosine x plus 2 sine x. If you are unsure of how we obtained this answer, you might want to check our previous video that tackles product rule questions. However, the purpose of this video is to tackle questions of the form of question B, and this is what we shall address next. We are required to find the gradient of the graph of g at x equals pi. So what you need to know is that the gradient of a function is obtained by differentiating the function. In other words, for the purpose of g of x, we have obtained this expression in blue, and this expression is actually the expression of the gradient of g of x at any point. So if I want to find the gradient or the slope at any point, I shall have to use this blue expression. And this is what we shall do. We want the gradient of the graph at x equals pi. So in order to find the gradient at a point, we substitute the given value, which is pi, into the general slope equation in blue, thus obtaining this orange expression, g dash of pi. I simply substituted every single x in the blue expression by pi. Next, we have to evaluate the values of this expression. So we have 2 pi times cosine of pi. Of course, 2 pi remains as is. Cosine of pi is equal to -1. This requires that you know the values of trigonometric functions, and in radians, cosine pi is cosine of 180. From the cosine curve, or by memorization, you should know that this is -1. This is added to 2 sine pi, and sine pi is equal to 0. Again, sine 180 degrees, or sine pi radians, that gives us 0. So the expression finally becomes -2 pi. So maybe take a minute to check the answer again, write it down if you will, pause the video because I'm about to start the next question shortly. Our second question in this video came in paper 1, May 2013, time zone 1, question number 3. Kindly take a look at the question and pause the video and then check your answer out. So for the first question, question number A, you are required to differentiate the function. Again, this is a product of two functions, x squared and sine x. We're going to use the product rule, uv dash plus vu dash. If you want this in more details, you are required to check out our previous video, but for the purpose of this video, the final answer is 2x sine x plus x squared cosine of x. Now for question B, again, like the previous question, we are required to find the gradient at a point. And as we previously said, the general expression of the gradient is found by differentiating the function. And to get the gradient at a specific point, we simply plug in the required value into the general expression found in blue on the screen. So we are required to find f dash of pi over 2, which is found by replacing every x with pi over 2. Next, you need to simplify and find the trigonometric exact values. So 2 times pi over 2 gives us pi. Sine pi over 2, which is sine 90 degrees, gives us 1. Pi over 2 squared remains as is, and cosine pi over 2, again that's cosine of 90 degrees, and that gives us 0. Finally, we simplify this expression in red, and we get the final answer of pi. So pause the video and take a minute to check this out, maybe write it down if you will. I'm about to begin the third question shortly. So the third question we are going to tackle in this video came in paper 1, May 2009, time zone 1, question number 3. Kindly take a minute to read the question and pause the video and then check your answer out. So you have the answer right there on the screen. Maybe take a minute to check it out, and I'm about to begin my explanation shortly. You are required in this question to find the gradient of the normal to the curve. So you need two pieces of information or two concepts in order to be able to solve this question. First concept is the fact that the gradient of the normal, which we shall call mn, is related to the gradient of the tangent or the gradient of the curve, which we shall call mt. And the relation is right there in blue in front of you. So this is a piece of information or a concept that you must know in order to solve this question. That mn is equal to -1 over mt. Now, mt, the slope of the tangent, is found by differentiating the function and substituting with the required variable, as we did before. So in order to find mt, I'm going to have to find f dash of pi, which means that first I'm going to have to find f dash of x. This is the sequence or the logic with which you have to approach this question. I need the gradient of the normal, so I need to first find the gradient of the tangent, so I need to first differentiate and then plug in the required value, which is x equals pi. So to differentiate this function e to the power of x cosine of x, I shall use the product rule, and I'm going to do this quickly like I've mentioned before. You have another video for detailed solutions. So e to the power of x cosine x gives me this expression, e to the power of x times negative sine x plus e to the power of x cosine x. In the first component, I kept the u and I differentiated the v, so this is u v dash. In the second component, I kept the v, so this is v, and I differentiated the u, so this is u dash. So this is uv dash plus vu dash. Now I'm going to substitute x with pi to obtain my second expression, which is f dash of pi. I just plugged pi for every value of x, for every instance of x, I replaced the x with pi. Next, I need to find the trigonometric exact values. You should know that sine pi is 0, so this expression is completely cancelled out. And cosine pi is -1, so we are left with negative e to the power of pi. However, in this problem, I am not yet done. I have found the derivative at pi. I need to translate this into the slope of the tangent and then the slope of the normal. If you have an idea of how to do this, you can pause. I'm about to give you the answer shortly. So as we mentioned, the slope of the tangent is simply the derivative at the required value. So f dash of pi gives me the slope at x equals pi. But this is the slope of the tangent. However, the question requires that we find the slope of the normal at x equals pi. and I simply just flip and switch to find the slope of the normal. The slope of the tangent was negative, so I'm going to switch the sign. So the negative of the negative gives me a positive value. So I go from negative to positive, and I go from numerator to denominator. Since it's negative 1 over mt, I simply switch the sign and flip my variable. So I have, instead of negative e to the power of pi, positive 1 over e to the power of pi. So maybe pause the video, take a minute to write this down if you will. I am about to begin the final question of this video. So the fourth and final question to be tackled in this video came in paper 1, May 2011, time zone 1, question number 5. Take a minute to read the question and maybe attempt to solve, so pause the video and then wait to check your answer out. So for question A, you are required to use the quotient rule to show the following derivative. This has been done in details in a previous video, a very similar question to this one where we had to use the quotient rule to find the derivative expression. So I'm going to go over this very quickly. First, we differentiate, we use the quotient rule, the normal formula, vu dash minus uv dash over v squared. Then we simplify, so in this case I just removed x squared, I cancelled x squared with 1 over x, so I got x minus 2x ln x in the numerator. Third step is to factorize, so I plugged out an x as a common factor, and what remained was 1 minus 2 ln x. Now in the fourth and final expression, I just cancelled an x in the numerator with one of the x's from the denominator, thus reaching the required final expression for g dash. My expression is exactly the same as the one found in the question above. Now the purpose of this video is to tackle question B. Question B says that the graph has a maximum point at A. This is a concept question. There is a concept that you have to know, and that is that the fact that there is a maximum point means that y dash equals 0 at this point. So if there is a maximum point, then y dash is equal to 0 at this point. So I simply have to equate the derivative function y dash or g dash to 0 in order to find the x value of the maximum point, which is a turning point or a stationary point. And you should know that a stationary point is a point at which the inclination of the curve changes, so the slope is 0 at this point and the tangent is a horizontal line. Now the slope expression is already found in question A right there. I just need to equate this expression to 0. You should know that any fraction when equated to 0 simply translates into equating the numerator to 0. So basically x minus 1 over 5 equals 0 just means that x minus 1 equals 0. I just equate the numerator to 0 because 0 over anything is 0. So I'm just going to equate the numerator to 0 right there. 1 minus 2 ln x equals 0. Therefore 1 equals 2 ln x. I just took the 2 ln x to the other side. Then I divided both sides by 2, obtaining this expression, ln x equals half. And I found the inverse of the natural logarithm, so x equals e to the power of half. Now we are done with the question. I just want to draw your attention to a small hint maybe, which is that whenever I have a show that question, whenever the question says show that, they're usually telling me that you are capable of solving the second question even if you do not manage to solve the first. So if I don't successfully use the quotient rule to obtain the required expression, I can just use the answer that they gave me to solve question B and therefore receive 3 marks out of the 7 that are there in the question. So just because you couldn't do A does not mean you should not attempt B. So take a minute to copy this down if you will. We are done. This is the final problem to be addressed in this video, and I hope you found it beneficial.